Like the mirrors, they come from a manufacturer in Germany. And like Flabeg, this company has had to reconfigure certain processes to meet the production needs of Nevada Solar One. Schott is known for a variety of glass products and tubes. But today, their plant is running at full capacity to manufacture the last of the receiver tubes needed for Nevada Solar One. The new power plant ordered over 19,000 of them. These are no ordinary glass tubes. Like the mirrors, their key ingredient is an unusually pure form of sand, free of the iron which clouds common glass. In a 1,650 degrees Celsius furnace, workers melt the sand into a malleable liquid. Then they shape it into a tube, cool it, and cut it into sections. Inside a top-secret assembly area, engineers marry the glass tubes with the inner steel tubing, coated in a special paint that absorbs 95% of the solar energy reflected off the mirrors. That efficiency is critical.
The better the tube performs, the better the output of the power plant, the lower the cost per kilowatt hour.
Finally, a machine pumps all of the air out of the tubes, creating a vacuum. Back at Nevada Solar One, workers are hard at work welding the receiver tubes in groups of 3. Then the team hoists the tube into its place on the frame in the exact focal point of the solar panels.
I do it first, guys. Back up.
The tubes are critical. It's going to carry the heat transfer fluid up to the generator. So it's going to actually be what receives the solar energy from the sun.
From the outside, a receiver tube looks like a simple device, but it's actually a technological wonder. The concentrated solar rays from the mirrors pass through the receiver's anti-reflective coating and then through the inner vacuum with little loss of energy. They hit the steel tube at the center, heating the liquid within. But now the surrounding vacuum acts as an insulator, preventing the heat from escaping.
It's exactly like a thermos, thermos bottle. It's 700 degrees inside the tube, and outside, you see I can put my hand, and it's not very hot. We can keep the heat inside.
These German-engineered components are highly efficient, and the key to Nevada Solar One's success. But the need to have them custom-made keeps startup costs high.
You have an automotive factory making those mirrors. They have to stop their production to do, for 2 months to do one power plant like this, and it costs them a lot of money.
But if Nevada Solar One succeeds and others follow, it could spawn factories dedicated to making solar components, and with them, lower costs.
When you're going to have a real industry, when you're going to have people build a mirror factory for solar plant, not for something else, that's when we're going to see a real cost reduction.
Some, like Gilbert Cohen, believe their high-tech, high-cost components are the right way to go for solar. But others want to get down and dirty to make their power.
But what we've been talking about is to get an intertie right there.
John O'Donnell is executive vice president of a solar startup company called Osra.
Where you could get some project in Arizona, some in Utah, some in Nevada.
His company has developed a new kind of concentrated solar power, one that they believe will finally make solar cheap enough to compete with traditional power plants. It's called the linear Fresnel system. It differs from older solar technologies in one central way. Trough and tower systems try to lower the cost of electricity by being more efficient, generating more heat from each mirror and tube.